We were at question number 9. Okay, we were almost done with question number 9. Okay, we were almost there. We were about to prove it. Is it visible? The screen is visible to everyone?
Yes, sir.
Yeah. Okay. So over here, me and Zeb, you were here, right? When we were stuck at this part, uh, that we were supposed to prove that angle AOB is equal to, 90 degrees. And we had proved these two things, and we will be using these. Did you do this question, Umer?
Question number.
Question number 10. No, question number 9.
Yeah, I did it.
Did that? Okay. Okay, so we were here, we were supposed to prove that they were equal and these two. So angle AOB is equals to 90. That is what we were supposed to prove. And we had proved these two things. And we can see here that angle POA is equals to angle AOC and angle BCO is equals to angle ACO, right? And what can we write about angle AOB? Angle AOB is made up of ACO, AOC, AOC plus COB, right? This is made up of this. And right, and is there anything else that we can do here? Omar, help me out here with this. Even in the last class, we were stuck here. What will we do here to prove that these are equal since you have already done this question? We need to prove that AOB is 90 degrees, right? We have proved these similarities and we have uh, we have this also with us. Angle COB is equals to angle QOB, right? And over here, BOQ, can we write this as AOC plus we can write this as AOC plus angle COB, and BOQ can be written as COB. Okay. Yeah, figured it out. Right. This can be written as 2 times AOC plus this can be written as 2 times COB is equals to 2 times. Yep. Are you following this, Zeb? In the last class, we were stuck at this step. Let me just go back. Right. In the last class, Zeb, let me know if I'm. Are you following this question first of all, Zeb? Let me
Yes,
know.
sir.
Yeah. In the last class, up we were right here, we were stuck here, we were done until this point and we were confused how will we use this angle ratio. Angle POQ over here is written as angle Q. This is angle POQ. Angle POQ was our 180-degree angle, straight angle, right? It was our linear pair of angle and it was 180 degrees, and we were sure that we will be using this straight angle or 180-degree angle to prove that angle AOB is 90 degrees. So when we proved our congruence in the last class, we did prove our congruence in triangle 1 and 2. This was our triangle 1, this is 2, this is 3, and this is 4. Right, we proved that angle POA is equals to angle AOC, and in triangle 3 and 4, we proved that angle QOB is equals to COB. These are the angles that we are interested in. POC is equals to AOC, and over here, these two angles are same. Right. So when we split our angles here, when we wrote this particular thing here, 180 degrees is equals to angle POA plus angle AOB plus angle COB. Over here, we were supposed to prove that 2 times AOB is equals to this, and we had to come to this point, right? But we were not able to. So what we did here is that we rearranged the things here. First of all, we wrote what AOB can be written as? AOB can be written as AOC plus, over here when you look at this, angle AOC, AOB can be written as angle AOC and COB, right? So this was QOB, BO, right? So over here, we already can see that angle QOB is equals to angle COB. So we can write this as this, and POC is equal to AOC. So we can write this as AOC. So now we can say that 2 times AOC plus 2 times COB is equals to 2 times of angle AOC plus 2 COB, right? And this would give you 90 is equals to angle AOB. Okay, is this clear now? Yep. Okay.
Yes, sir.
Let's move to question number 10 then. Okay. Prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact at the center. Okay. So we will need to draw a diagram. Let me close a few tabs that are open in the background. This, why is it getting, okay. Okay, so one thing in this chapter that I have been making mistakes with while solving questions or understanding questions is that there is this one particular sentence that this chapter is repeating, that angles are supplementary to some angle that is subtended, or anything that has to do with that. So over here we are being asked that this particular sentence, please don't get confused in this, like I have been, and ended up feeling that I'm stuck, but the question was done. So over here, we are being told that angle between two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact at center. When they are telling us that when the angles are supplementary to the angle subtended, whenever the supplementary thing is coming into the question, into the context, that means that, let us just draw the figure and understand that we have a triangle here, we have a circle here, and from an external point we are drawing two tangents to it. Okay, so from this point there are two tangents. Hmm, right, from this particular point, point A. So from point A, there we are being told that we are looking at the angles drawn from angles between tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact. So where are the angles being subtended? At the center.
Yeah.
So we have our points of contact A, and this is point of contact B. So this line AB is also subtending angles at this particular place. Okay, let us call this point C. Okay, so we have this. So this particular angle. So what we are being told, this line, last line, prove that the angle between the two tangents from an external point to a circle is supplementary to the angle subtended by the line segment. Is supplementary to the angle subtended. The first angle between two tangents is supplementary to the angle subtended by the line segment. Basically meaning angle A, angle APB plus angle ACB is equals to 180. This is what is supplementary to the other angle means. Okay, I did not understand this line, and I was stuck at this question thinking that I could not get the answer. So this is what it means, that one angle is supplementary to the other. Okay, it was very basic. I went back to the basic linguistic of the supplementary angles. That is what we mean by supplementary angles, right? If we are added, we get 180 degrees. If they are acute angles, they give 90 degrees or less than 90 degrees, right? The what angles do we have? Reflex, supplementary, and then what is one another pair? Linear pair,
Complementary.
complementary, right? Complementary is 90 when they add up to 90. Okay, so we need to prove this. So what we can see here is that these two angles are going to be 90 degrees, right?
Yeah.
So basically angle CAP is equals to 90 degrees. Angle CBP is equals to 90 degrees. These two are 90 degrees. If these two are 90 degrees, then we need to understand that this is forming a quadrilateral. Okay, this is forming a quadrilateral. How? The quadrilateral that we can see here is ACBP, right? This is one side, this is the second side, this is the third side, and this is the fourth side. Okay, this is the quadrilateral that is forming, and inside this quadrilateral you can see that angle CAP is 90 degrees, angle CBP is 90 degrees. So what do we know about a quadrilateral? That the sum of the interior angles of a quadrilateral are 360 degrees, right? So in this quadrilateral, what we can say, angle ACB plus angle CBP plus angle BPA plus angle PAC is equals to 360 degrees. Over here, we are already aware that angle CAP is 90 degrees and angle CBP. Where did we write CBP? Did we repeat one angle? ACB, CBP, BPA, and PAC. Okay, PAC. This is 90 degrees, right? So ACB plus angle BPA plus 180 is equals to 360 degrees. That would give us angle ACB plus angle APB is equals to 180 degrees. This is the answer. That's it. Okay. There is nothing else to this question apart from understanding this simple language and solving it. Any doubts in this?
Awesome.
No? Okay. Let's move to question number 11. Okay. Question number 11 talks about a parallelogram that is circumscribing a circle, and we need to prove that that parallelogram is a rhombus. Okay, what is a parallelogram? If I say that ABCD is a parallelogram, let us parallelogram is a quadrilateral where the opposite sides are parallel and equal, right? This is AB, this is CD. Okay, that means AB is parallel and equal, AD is parallel and equal, right? AB is equals to DC and AB is parallel to DC. And similarly, AD is equal to BC and AD is parallel to BC. This is what a parallelogram is. Now for this to become a rhombus, what is a rhombus? What are the qualities of a rhombus that makes it a rhombus? Zeb, what is a rhombus? What do you, what is equal in a rhombus? Like what does it make? How do you define a rhombus? We know that
A
square is a fifth.
parallelogram with all sides equal.
Yeah, that is true. What about the diagonals?
The diagonals bisect each other.
Bisect each other. But are the diagonals equal? The diagonals are not equal in a rhombus. Okay. All sides are
Yeah.
equal. All sides are equal, but diagonals are not equal. You're following us, Saad, here?
Yes, sir.
Yeah, do pay attention. Do not really, uh, assume that these classes are fleeting. Okay. Do pay due attention to them. Okay. Exams are very near. Okay, so to prove that it is a rhombus, we need to prove that AB is equals to DC is equals to AD is equals to BC, right? We need to prove all of this. Okay, but we already know that this is the case and this is the case. Why? Because it's a parallelogram. So let us make this figure and see how we can prove that this is going to be the case, that it's going to be a rhombus. All right. All right, this is a circle. Let us make our parallelogram. Okay. Okay, so if this is a parallelogram, let us name the points here. Okay, this is going to be point A, this is going to be point B, this is C, and this is D. Okay, so what we can notice from this parallelogram is that from point A, we are subtending to, let us name this point D, E, F, and E, F, G. Okay, what we can notice here is that point A, B, C, D, while being the vertices of this parallelogram, they are also projecting, they are also making tangents to the circle, right? And while they are making tangents, what we can say is AG is equals to AD, length of tangent. Can we say that?
Yeah.
And then from BG is equals to BF. This is length of tangent. And similarly, CF is equals to
That
CE.
angle OT, sir.
Angle
LOT.
LOT me not angle LOT. It is length of tangent. That's LOT. That's LOT. LOT. Okay. Length of tangent is equal, right? From an external point, when we are drawing tangents, the length of tangent is going to be equal from the point of contact to the point that is, making the tangent. You guys, it's clear, right? It's the basic theorem that we studied in the beginning. Is it clear to everyone why length of tangents are equal?
Yes, sir.
Yeah. So CF and CE are going to be equal, and then DE is equals to um okay, we need to change this point. Let us make it XE. XE. So that would be DE is equals to XT, length of tangent. Okay, so we have this with us. Now we know that AB is equals to DC. And then similarly, we also know that AD is equals to BC, right? Because they are parallelograms. Now we need to prove that AB is equals to DC is equals to AD is equals to BC. Okay, let us now, what is going to be a recurring theme in this, that we will be writing these things, this length of tangent, and we will be using them to rearrange and prove our case of, this particular thing. AB is equals to DC is equals to AD is equals to BC. Okay, we need to prove this. So let us add the given case to us on this side, and let us rearrange the terms. AG plus BG plus CF plus DE is equals to AX plus BF plus CE plus XT. Okay. What is AB made up of? AB is made up of AG plus GB. What is DC made up of? DC is made up of DE plus AC. And what is AD made up of? AX plus XT. And BC is made up of BF plus FC. Okay, so since this thing goes both ways, okay, when I'm highlighting these things, this means that they both go, say, right and left. Okay, LHS equals to RHS, so we can swap BG for, you know BG for BF, and then we can also swap BF for BG. Similarly, we can swap CE for CF somewhere, and then we can also swap XD uh, for CF, and for DE we can swap XD. Okay, so over here we can notice this, that to make this over here, let's see what is AG and plus BG. AG plus GB would give us, what? AB. So AG plus BG would give us. So let us write this. This would give us AB. All right. What would CF plus DE give us? Would CF plus DE give us anything? Let us look at it. CF plus DE. CF plus DE would give us nothing. But we have this, this with us. If we can convert this to something that will make it BC, let us look at it. CF plus DE. What is DE? DE
Sir,
is equal.
if you arrange it in the correct order, it will come.
Yeah, we can swap the things also, right? To rearrange it. Right. Instead of the CF, if it is CE, what is DE plus, what is CF equal to here? CF is equal to CE, right? CF is equal to CE from this. Can I write over here CE plus DE? What would CE plus DE become?
CD.
DC, right?
Yeah.
We can do that. And what about AX plus BF over here? AX plus BF. What is BF equal to? What will we need with AX?
AX plus XD is AD.
AX
DF,
plus XD, AD. And then BF plus CE. BF plus CE. What is CE equal to? BF plus CE. CE की जगह पे we can write CF. So this would give us AD plus BF plus CF is BC, right? So this would be AB plus DC is equals to AD plus BC, right? And we know that AB is equals to 2 times DC is equals to, what can we say about AD is equals to BC? We can say that it is equals to 2 times AD. So that means DC is equals to AD, right? And if we can say this, and we already have AB is equals to DC and AD is equals to BC, since if these two are same, then AB will be equal to BC. And by that, we can say that they are all equal to each other, right? Is that making sense? Did it make sense, everyone?
yes, sir.
Yeah. Saad and Zeb,
Yes, sir.
answer me. Yeah. Did it make sense? All right. Okay. All right, so let's move to the next question. Okay, we will be using this a lot. Okay, if you get the hang of this particular trick here and this particular trivia that we'll be using again and again. Okay, let us move to question number 12. Okay, question number 12 is, okay, we did this once. Let's do it again in a clear way this time. So over here we have a triangle which is circumscribing a circle of radius 4 centimeters, and let us remove this and prove that a triangle ABC is drawn to circumscribe a circle of radius 4 centimeters such that segments BD uh, and DC, into which BC is divided by point of contact DR of lengths 8 centimeter and 6 centimeters respectively. Find the sides AB and AC respectively. Find the sides AB and AC. Okay, so we are being told that this is a triangle and this triangle is circumscribing a circle. When circumscribing, it is also touching the circle, right? Circumscribing basically means that it is going to touch the circle. The polygon is going to touch the circle. Okay, all the sides of the polygon will touch the circle. So over here, all three sides are touching the circle. In this, what we are seeing, what we are observing is that when we are drawing a line from O to D, okay, this line segment is being divided in this ratio, in this size, 8 centimeters and 6 centimeters. And we are being told to find the length of sides AB and AC respectively now, AB and AC. So we know AB is unknown, BC is given to us, which is BC would be 14 centimeters, and then AC is not known to us. Now we need to find that radius of the circle is given to us. Radius is equals to 4 centimeters. Okay. Now, how do we go about it? Okay, last time when we did that, we roughly have an idea from the last time uh, that we will be using Heron's formula. Okay, Heron's formula, and then we will also be using the concept of length of tangents. All right, and we'll be making a few triangles here. So first of all, the first triangle would be formed by this, right? And this, and then the next triangle would be mm,
Okay.
okay. Now what you can observe here, let us name these points. This is D, let us name this E, and this as F. What you can observe here in length of tangents, first of all, is that BD is extending to tangents. That means BD is equals to BE, right? If that is going to be the case, can we say that these two triangles are congruent to each other by RHS? Let us observe triangle in case of BDE. Let us observe triangle uh, DOE and triangle DOE, BOE, DOB, sorry, DOB and BOE. Okay, over here you can notice angle ODB is equals to angle BEO, or let us write it as OEB, which is 90 degrees, right? Is this clear why these angles are 90 degrees, right? If it is not clear, do let me know. Okay, and then we can say that OB is the same side, right? OB is the same side, and then OD and OD is equals to OE. This is radius. So OB is the hypotenuse, and this is the radius. This is one side, and this is our right angle. So by RHS, these two triangles are congruent, right? So let me name them. Let me mark them so that we can understand which two triangles we are going to talk about. Okay. So triangle 1 and 2. Let us use a different color. Yeah, I need to do something about my pen. 1 and 2 are same, right? And then 3 and 4 will also be same. Can we say that? Because AF will be equal to AE, and then AO is being the same side, and then OF and OE will be the radius, right? This is the case. And then the other pair would be okay. The other pair 5 and 6. Okay. So can we say that all these triangles are all these two pairs are going to have the equal area also, right? So how will we now use Heron's formula to find the length of the two sides? Okay, so Heron's formula is going to be what is Heron's formula, anyone? It is S into S minus A into S minus B into S minus C. uh, this is Heron's formula, right? And S is the half perimeter, right? um, this is the case. How can we find the perimeter of this triangle, half perimeter? Anyone? How can we find the perimeter of this triangle?
By equating it with the half pH.
By equating it with? By equating it with what, Umair?
By half pH.
by half BH. That would be the area actually. Say that again.
In Heron's formula, that one extra side by equating with half BH.
One extra side with half BH. Hmm. One extra side. See. Hmm. Which extra side are you talking about? We have only three sides, right?
In the angle 1, we know 8, 4, and but we don't know OB. So if we equate it with
Hmm. This is going to be the area of triangle, whole triangle, right? And we know that this is going to be A, this is going to be side B, and this is going to be side C, right? Perimeter is A plus B plus C. 2 times perimeter is going to be 2S is equals to A plus B plus C, right? This is what the formula says. We know only A here. We do not know the sides B and we do not know the side C also, right? Length of these two sides. And we need to find this.
C is, but we know AF is equal to AE.
AF is equals to AE.
We know CF is 6, EB is 8.
Oh, length of tangents, right? We can use that. So this would be 6, this would be 8, BE. And we can call these as X and Y. No, these are also going to be same because they are length of tangents again, right? So we can say that instead of B plus C, we can write, instead of B, we can write 6 plus X, and this would be 8 plus X, and A would be 14, right? So this would be the perimeter. 2S is equals to 14 plus 14, 28 plus 2x, right? S would be equal to 14 plus x, right? And let us take B as 6 plus 8 plus x, B as 8 plus x, and C as 6 plus x. Okay, so what can we say about this is that if we equate the area of this whole triangle, this represents the area of the whole triangle, right? This area of the whole triangle, we can equate it to the twice the area of, we have 6 triangles here, right? If, and we can use the known values in this triangle, we can equate it to, we can say that this whole triangle area is 2 times triangle area ODB. We can use ODB, and we can use ODC, and then we can use triangle area OD, OAC, OAF. Can we say that?
What is the value for OA?
OA?
Yeah,
For OAF, that's OAF. OAF is going to be X, right? For OAF, we will be using 4 times is going to be our height. 4 is going to be our, the radius is going to be our height, and the base would be X, right? Is that making sense? So if we start writing for triangle ODB, it would be for OD, for all of these, the bases would be same. Can we say that? No, no, the bases will not be the same. The height will be the same for all of this because it's the radius, half into base into height plus half into base into B1, B2, H would be same for all of them. Is it making sense, Umair and Saad and Zeb?
Sir.
Yeah. So we can take out 2 into 1 by 2 and H as common from all of them. So we'll be left with B1 plus B2 plus B3, right? So the base one would be first base, we can take it as 8 centimeters. We took a ODB, and then the second base we can take as ODC, which is 6 centimeters. And then the third base we can take as X, which was for OAF, right? And then we have H outside. H would be, what is H? 4, right? Which is going to be 4 into, what is 8 plus 6? 14 plus X, right? So what were we equating this whole thing to? This whole thing was equal to what? Area of triangle,
C.
triangle area,
PC.
triangle area ABC. And what was that written in the form of S into S minus A into S minus B into S minus C is equals to 4 into 14 plus X. If we multiply this into this, that would be 1656 plus 4X, right? And over here on this side, what was the value for S? Is equals to A plus B plus C. Let us just bring it down from top. The value for S was 14 plus X, and A was 14, B was 8 plus X, and C was 6 plus X. So S was, what was the value for S? 14 plus X. So this would be 14 plus X into 14 plus X minus 14 into 14 plus X minus 8 minus X into 14 plus X minus 6 minus X is equals to 4 into 14 plus X. Okay, and this would all be under root. Okay, now what will be the values for the stuff inside? This would be 14 plus X. This would cancel out this, and this would be X. And over here, X and X, 14 minus 8 would be 6. And over here, this and this will get cancelled. 14 minus 6 would be 8. Over here, this would be 14 into 14. Okay, now over here, this would be 14 plus X into 48x is equals to 4 into 14 plus x. Now we can square on both sides since there is no further simplification that we can do. So this would be 14 plus x into 48x is equals to 16 into 14 plus x whole square, right? And this would give us, we can cancel out this 14 plus x and this 14 plus x, and this 16, can we do something? 16 threes are, yeah, 16 threes are is 48. So this would be 3x. This would leave you with 14 plus x. This would give you x is equals to 14 minus x. 2x is equals to 14. X is equals to 7. So if x is equals to 7, we took these sides to be 6 plus x, 8 plus x. So this would be 7 and this would be 7, meaning the side's length would be 13 and this side's length would also, the side's length would be 15, right? And this side's length was 14. So this is a scalene triangle. Is it clear, everyone? Last time it was very incoherent. It felt confusing because I did not understand it properly using the length of tangent sides. Is it clear?
Yes, sir. But
Yep.
4 plus 14x when we square. Okay.
Sorry,
Nothing, sir.
is it clear? We
Yeah.
squared it on both sides, right? And we have 14 plus x both sides. So that is why we were able to eliminate 114 plus x. Okay. So the last question, let us move to that.
So can you go down?
Okay, take a look.
Um, 16 gets cancelled with 48.
Sorry,
15 gets cancelled with 48.
16, yes, 16 ones and 16 threes. 16 threes is 48, right? So that is why 16 ones and 16 threes. That is how we end up with 3x is equals to 14 plus x.
Yeah. Okay.
Okay. All right. Let's prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center. Okay. Let's take this question. Hopefully we will be able to cover it in the next 10 minutes. Okay, let's take a circle. So we have a circle with us and opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles, meaning now when we have a quadrilateral here, okay, when this is going to hmm, just a second, it's stuck. All right. Okay, so this is a quadrilateral now. Now what we can see here is that this is A, this is B, this is C, and this is D. Okay. Now what we are being told is that AB is opposite to DC, AB opposite to DC. Uh, let's read the question. Opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center. Meaning this side, meaning this angle, this angle. Okay. Angle AOD is equals to angle AOD plus angle COB is equals to 180 degrees. We need to prove this, and then we also need to prove angle AOB plus angle COD is equals to 180 degrees. Okay, this is what we need to prove. All right, so let us look at it how we will prove it. Okay, they are subtending supplementary angles at the center, meaning we will add them, then that will become 180 degrees. Okay. All right, so over here we can see about triangles. We can point of contact. So this would be point X, this would be point Y, this would be point X, Y, X, W, X. Let us take W, X, Y, and over here Z. Okay, so over here we can see that we are forming triangles, and can we use them to prove that the angles are going to be 180? Mm,
Yes, sir. By RHS, you can prove that they are similar. Then you can say angle. You can say like DOY angle DOY plus angle DO, what's the letter? Z, DOZ are equal. So you
Mm,
similarly we can prove all are equal, and like the way we prove rhombus, parallelogram is a rhombus, we can add everything and prove it is
mhm.
supplementary.
Okay, let us first name the angles 1, 2, 3, 4, 5, 6, 7, 8. We need to prove that angle 1 plus 2 plus angle 5 plus angle 6 is equals to 180 degrees. And then we need to prove angle 3 plus angle 4 plus angle 8 plus angle 7 is equals to 180 degrees. Okay, this is what we need to prove. By congruences, we can prove that uh, la- triangle DOY and triangle YOC. Triangle DOY and triangle YOC. What can we prove here? OY is equals to OY. That's the same thing. 90-degree angle, 90 degree, and OD over OC. How can we use similarity here, Umer? We will use
Similarity, congruence.
congruence, right? We will be using congruence. We cannot use similarity, right? Hmm. Mm-hmm. Can you repeat what you just told about the solution? Let's see.
First we prove ZOA and OAW are congruent.
ZAW and OAW. Okay, so the ones that are forming length of tangents, those we will prove.
Yeah.
Okay.
Then
That.
we say by CPCT 1 is equal to 8.
Mm-hmm. Yeah, that is
So
much.
similarly we can prove 2 is equal to 3, 4 is equal to 5, 6 is equal to
Mm.
7.
Just a second, Umar. Just a second, guys. I need to take a call. Hello, guys. I will just be back in 5 minutes. Okay, let's end the class here. We just have 5 more minutes, anyways. We will take this question up again, but I think one thing that we have learned here, you and I have learned, is that we should not forget length of tangents. If we understood that concept here well, we will be able to solve these questions pretty well using similar congruences and other things, right? Over here, radius, yeah, these triangles will be congruent. So angle 1 is equals to angle 8, angle 2 equals to angle, yeah, angle 2 equals 3, angle 4 equals 5, angle 6 equals 7. And then we can add and rearrange them and show that they are 6 equals 7. Yeah, we can show that if we add them, we can show that they are we can show something about them. They all add up to 360 degrees, and we can show that they are, yeah, we can do something about it. Let's take this up on the next class. Okay, hope Umair's syllabus is sort of completed with this chapter now that it's completed. Yeah, if you have any doubts, let's take it up in the next class, Umair. But so as far as NCRT is concerned, we have completed all the questions, right? Except that one example, but we can take that up since the exam is far away, right? Still, there's time. We
Yeah.
have many classes before that. Okay. Uh, there's a test on 4th, okay, a weekly test. So I think the syllabus I will, so far we have completed coordinate geometry. Last test was on coordinate geometry. So I think this time I will give circles. okay, or applications of trigonometry, and one of those, and only questions that we have done and learned are from NCRT. Okay, so do give that test well, and if I have MCQs in that, do solve the MCQs. Okay, please, because that is for your own understanding and for my understanding also, that how far you have learned. Okay, so let's end the class here. Okay, there's a chat. Let me just. Saad, today I cannot, man. I have another demo after this. So,
Okay.
is there a test for you? Is there a test?
No, sir.
No.
Yes.
Let's take it up in the tomorrow's next class. Okay, on Tuesday. Okay. I have to take a delivery out, so that is why I cannot do that and then come back for the
Okay, sir.
demo. Okay. Okay. All right. Take care. Bye bye, guys. You can leave the class. I will also. Okay.